Hello, my name is Yashad Gurude, and this is my Physics 2211 Lab 1. So for the purpose of this lab, the purpose of this lab is to observe an object in motion. So in this case, I used a water bottle rolling down the floor, across the floor, and it had constant velocity, and I experimented by finding the predicted results of the water bottle, and I compared it to the ones I observed in the actual video that you'll see later on. And here is just some pictures using that show Newton's first and second law. So as you can see, this one shows Newton's first law is like an object in motion will stay in motion. So like this pendulum ball will hit each other and they'll stay in motion unless someone stops it. And this one is Newton's second law. The force F acting on a moving object is the product of the mass and acceleration, so F equals ma. So the background of this lab is that Newton's first and second law, as we discussed in the previous slide, constant velocity and net force. So right here you can see the forces are balanced. An object at rest will stay at rest and acceleration is 0. An object in motion stays in motion, acceleration is also 0. And this is the formula for final velocity that we used, and it uses force and delta t. So before we go to the model code, let's look at the tracker. And right here, this is the video that I had for my water bottle rolling down, and on the right you can see this graph as well as this table. So let me just play the video. So yeah, that was just half the video, but you can see that as the water ball is going down, the graph progresses with a negative velocity, and this table as well shows the points. So then back to the model code. As you can see down here, the ball mass, I set it as 1, and I put in the ball velocity vector with the velocity that I predicted from the points, as well as the delta t, which I found through the points. And then on this right side, you can see the while loop, which takes which finds a ball position and it adds it with the vector that I created. And the while loop lasts for 7.44 seconds because that's how long the video is. So next is the observed and expected graphs. So as you can see, the graphs are pretty similar. There's a little bit of variation because in the beginning the water ball is stopped, and so it doesn't move, but as the water ball keeps moving, they have the same velocity right here. Yeah, they both have the same constant velocity, so the graphs are pretty similar with the observed and predicted graph. So the questions, so what if, how will orientation of axis affect results? The orientation of axis will not change much except the direction of the velocity, as like if you flip the axis, it'll change the direction of velocity, but because there's no such thing as negative magnitude, the magnitude will be exact same no matter how the axes are oriented. And what does this mean? So why is net force 0? Since velocity is constant, there's no net force. So basically, like all the forces on the water bottle are being canceled out by another opposing force, such as like gravity is being canceled out by normal force, as well as the force that we push the water bottle with is being canceled with friction and stuff like that. So that's why there is no net force in the predicted. But obviously, like when I observed it, there was a little bit of net force because you can't take account for everything, so there's a little bit of friction, right? And I couldn't get rid of that. But yeah, thank you.